Come on, hurry up. Phew, I just got here just in time. Now let's head to level 3. Oh, many biotechnologists are already here. Wait, you might be wondering what's happening here?
Flashback.
Is that true? We found a new bacterial strain?
Yes, call everyone. We're having an urgent meeting today.
Got it. So, we have all gathered here to discuss this novel discovery. However, its potential or its risks still remains unknown. So, what's important is we need to get this bacterial strain safe first. Therefore, we have called in a science officer of UPM Microbial Culture Collection Unit to brief us on how to preserve this strain for future research. So, there are a few reasons why we need to preserve microorganisms. First, the properties of each strains are different. Isolation of some strains is also difficult. We need to keep it in Culture Collection Center in order to propose a new species. In addition, some microorganisms could die and its properties could change over time. So in this meeting, several preservation methods were proposed and discussed, and what we're interested in is the freeze-drying method, which is suitable for batch production and distribution, with undemanding storage requirement. Besides, it is extensively used for bacteria, yeasts, spore-laden fungi, and some viruses, with about 50 years longevity and good genetic stability. Pointless Liana then explained the freeze-drying process. The methods start with fully grown culture, mixed with protectant skim milk plus MSG, which later filled in ampoule. Next, into the freezing phase. First, freeze it in minus 20 degrees Celsius freezer, then in minus 80 degrees Celsius freezer, both for 1 to 2 hours. After that, primary drying and secondary drying take place to remove moisture and bound water, respectively. The ampoule is then sealed under vacuum and stored at 4 degrees Celsius. Now, let's move on to the MCC unit to delve further on the freeze-drying preservation method with 20 Mayura. So this is the freeze dryer from Lab Quantico, and its key components include vacuum pump, condenser, vacuum chamber, and adapter. Juan Umaira explained that the ampoule taken from the 80 degrees Celsius freezer was immediately placed in a beaker and transferred into the freeze dryer chamber for the primary drying process. After overnight drying, the ampoule was attached to the adapter for the secondary drying process. To seal the ampoule, 2 gases are used. LPG with yellow flame and oxygen gas with sharp blue flame. And this is how the ampoule looks like after freeze drying. The quality control of the freeze-dried culture was done before and after preservation and also before storage. Colony counting method was done to measure the concentrations of the cultures. If the concentration dropped drastically after the preservation, then another method or protectant shall be suggested. The vacuum testing was done 2 to 3 weeks after the sealing process to ensure complete vacuum condition in the ampoule. A Tesla coil, also known as spark tester, was used for the vacuum test. If a pale blue spark appears, it indicates a good vacuum and a properly sealed ampoule. Juan Umaira also explained how the freeze-dried culture is transported. For short-distance transport or collection, the ampoule is simply wrapped in bubble wrap and placed in a courier envelope. For long-distance transport, the biological material transport system is applied, where the ampoules are stored in a primary box, which is then placed in a secondary box filled with styrofoam and bubble wrap to prevent movement. The box must also include the recipient and sender details, along with the biological substances Category B label. Hence, with the guidance of the UPMMCC science officers, we decided to preserve our bacterial strain using the freeze-drying method. For more details information, here's the reference list. Thanks for watching.